Hello and welcome to lesson number 14 in the Python tutorial series. The topic of today is going to be nested functions, and it's a pretty simple concept actually. It's the idea of running a function inside a function that you've created. So you've got a function in a function. If you do an internet search for nested functions on the internet though, a lot of the websites, in particular when you do searches for Python help, a lot of times it goes to Stack Overflow, and Stack Overflow is a great resource, but for beginning programmers it throws a lot of examples at you that might not be all that accessible. So this should be a fairly straightforward and quick lesson. We're going to create a real-world example of how you would use nested functions, and then we're going to head on over to the Python visualizer from the previous lessons and evaluate how Python interprets a nested function. The only other thing we have to do after nested functions is go over the importation of the time module. That'll be lesson number 15, and then we'll be moving on to our next project. So that's what we're looking at for the upcoming lessons and where we're going. And so let's go ahead and get started with nested functions. Okay, so we're over here in our Python shell in our programming window, and the way we're going to provide an example for nested functions is with converting temperatures. You may not be familiar with it, or it might be something that you haven't done since maybe the last time you took a science class, but there's really three ways to measure temperature. There's Fahrenheit, which in the United States, Fahrenheit tends to be the most common way to measure temperature. You also have Celsius, and then you also have Kelvin. In order to convert Fahrenheit to Celsius, you take the degrees in Fahrenheit minus 32 and multiply it by 5/9. Or you take 5/9 Fahrenheit minus 32. And I'll put that formula up on the right-hand side of the screen so you can take a look at it. But that's how you convert a temperature in Fahrenheit to Celsius. There's also a measure of temperature called Kelvin, which is often used in astronomy. And the way that you convert, or the way that you get a Kelvin temperature is you take Celsius and add 273.15. So in order to easily get Kelvin, you need Celsius, and in order to easily get Celsius, you need Fahrenheit. We're going to provide an example of how to take a Fahrenheit temperature and convert it to Kelvin in a single function. So let's go ahead and just start by going over to our programming window and creating a function that will take a Fahrenheit temperature and convert it to Celsius. So I'm going to call it far2cell. That's going to stand for Fahrenheit to Celsius. And in order to convert a temperature in Fahrenheit to Celsius, I need to provide the temperature in Fahrenheit. So this function, we go ahead and put our comment in, converts a temp in Fahrenheit, I think that's how you spell it, to Celsius. Okay. And in order to do that, we're going to say that Celsius equals, the first thing we need to do is take Fahrenheit minus 32, and you can see I use far here. That stands for Fahrenheit, and I'm passing that in. The parameter for this function is that I need to provide a temperature in Fahrenheit. So to start off, we're going to take Fahrenheit minus 32, and we want to take 5/9 of that number. We want 5/9 Fahrenheit minus 32. Put these in parentheses to make sure the order of operation goes through correctly. Otherwise, this 32 times 5 would occur first. So we take Fahrenheit minus 32 and then multiply it by 5/9. And then I'm going to return Celsius. And let's go ahead and run this program. I'm going to name it test.py. And I'm going to run Fahrenheit to Celsius and just put in a number, let's say 98 degrees. And it returns 36.6667. In order to test this, I really want to provide a number where I know what the answer is going to be. Well, and I know for a fact that 32 degrees Fahrenheit is freezing and 0 degrees Celsius is freezing. So let's try Fahrenheit to Celsius and put in 32 degrees. And that should give us 0, and in fact it did. I also know that the boiling temperature in Fahrenheit is 212 degrees, and the boiling temperature for Celsius is 100 degrees. So if I type Fahrenheit to Celsius with 212 degrees as my argument, I should get 100, and indeed I do. So my Fahrenheit to Celsius conversion function is working okay. Okay, and before we write our next bit of code, there's a couple of very bad spelling errors in there, and I'm very sorry for it. First off, Fahrenheit was misspelled. There was an H in Fahrenheit. In addition, perhaps the more irritating one is Celsius was misspelled. That has an S and not a C. So I'm going to adjust my program to correctly spell Celsius. If I was in the viewing audience of my own programming tutorial right now, I would have been tearing my hair out at those misspellings. So we've got those fixed now. The next thing we want to do is we want to write a function that's going to convert Fahrenheit to Kelvin. So I'm going to write a function, Fahrenheit to Kelvin, and provide a temperature in Fahrenheit. And this function will convert a temp in Fahrenheit to Kelvin, and the formula is Celsius, I almost did it again, plus 273.15. Now one way I could write this function is Celsius equals, and then just like I did in the function above, Celsius equals Fahrenheit minus 32 times 5/9, and that will give us a correct Celsius right there. And then I can take that Kelvin equals Celsius plus 273.15. And then finally I could return Kelvin. That is a valid way to write this function, and it would work correctly. When we run this function, if I did Fahrenheit to Kelvin and provide a temperature of 32, I should get 273.15, and that's because Celsius would be 0, and 0 plus 273.15 is 273.15, and indeed that happens. Now, if I also know if 212 degrees Fahrenheit is 100 degrees Celsius, then 212 degrees Fahrenheit should be 373.15 Kelvin. So I'm going to do Fahrenheit to Kelvin at 212. And so this conversion is working correct. Now, there is no nested function in here yet. But one of the things that you want to do as a programmer is minimize your chances for bugs. If we've already converted Fahrenheit to Celsius up here, we're recreating that mathematical formula down here in this function as well. If we made an error, just let's say we did 5/8 here, what we would have is a bug that is much harder to find because the conversion from Fahrenheit to Celsius occurs twice in our program, once in this function and once in the Fahrenheit to Kelvin function. To minimize the chance of bugs, instead of rewriting the code that I already wrote in my Fahrenheit to Celsius, I'm going to say that Celsius equals Fahrenheit to Celsius, and I'm going to pass as an argument Fahrenheit because I provided that here as my parameter. So instead of manually converting Celsius, I'm going to have Celsius call the Fahrenheit to Celsius function and get its number that way. The advantage to doing it this way is that my formula to convert Celsius only occurs in one function. That way, if there's a problem, I only have to search for it and correct it once. If I run this program, I should get the exact same results because this conversion right here is doing the same thing, it's just doing it in a different place. So let's test Fahrenheit to Kelvin with 32, and indeed I still get 273.15, and Fahrenheit to Kelvin with 212, I still get 373.15. This is what's called a nested function. I'm inside my own user-defined function here, and from this function I'm calling a second function. So the next thing we're going to do, now that we've written our Fahrenheit to Celsius and Fahrenheit to Kelvin converters, is we're going to put them into the Python visualizer to see how they're handled by Python. Before we can do that, though, we have to make a slight change to this, and that's because the Python visualizer doesn't act as the shell. What that means is we have defined Fahrenheit to Celsius and Fahrenheit to Kelvin, but we never make a function call, which means they're never going to execute. So the first thing I'm going to do is I'm going to set x equal to Fahrenheit to Celsius, and let's say we're going to call this 45 degrees Fahrenheit. The next thing we're going to do is set y equal to the Fahrenheit to Kelvin, and let's do that at 112 degrees. So now we have two function calls, Fahrenheit to Celsius with 45 degrees and Fahrenheit to Kelvin with 112 degrees. So we're going to copy and paste that into the Python visualizer. One important thing that you're going to have to do, and I didn't talk about this in the previous lessons, is your code might be executed using Python 2.7. I think that's the default for the Python visualizer. If you execute this code in Python 2.7, it's going to change the way division is handled, and it won't work correctly. So don't worry so much about what Python 2.7 is doing. Just know that in order for this to work, you have to execute your code using Python 3.3. And let's go ahead and visualize the execution. So the first two things that happen, the first two lines that execute, are adding Fahrenheit to Celsius and Fahrenheit to Kelvin into the global frame to be called. Line 13, the next line that's going to execute, is going to call the Fahrenheit to Celsius function, passing in a value of 45 degrees Fahrenheit, and assign that to a variable x. So Python's going to head back up to line 1. It's going to do its conversion. It's going to create a variable Celsius, which is equal to Fahrenheit minus 32 times 5/9, which equals 7.22222, and then it's going to return Celsius. Celsius is in that local frame at 7.22222, and it's going to return a value of 7.2, and x is assigned that value. So watch what happens now when we execute the Fahrenheit to Kelvin function. It heads up to line 6 to run the Fahrenheit to Kelvin, and it passes in the argument of 112 degrees, so Fahrenheit is equal to 112 for this execution of the function. Celsius is now told to use Fahrenheit to Celsius as a different function and pass in the value of Fahrenheit. So it goes to its local frame and says, do I have a Fahrenheit variable? And I do, and it's 112. So I'm going to pass that into the Fahrenheit to Kelvin, or the Fahrenheit to Celsius function. You can see now, if you look at the global stack, we have Fahrenheit to Kelvin running, but we've left that frame and gone to the Fahrenheit to Celsius frame. So we're still only in one frame, but we're now in a function call within a function call. And we have two variables, Fahrenheit 112 in the Fahrenheit to Kelvin function, and Fahrenheit equal to 112 in the Fahrenheit to Celsius function. Just like it did last time, the Fahrenheit to Celsius function will execute. It will create a variable Celsius, which is now equal to 44.4, and return that value. That return value from this function is going to be assigned to the variable Celsius. And indeed, Celsius gets a value of 44.4. Now the Kelvin conversion can work, so Kelvin equals Celsius, which is 44.4, plus 273.15, meaning that Kelvin is equal to 317.594, and then it returns that value. You can see here that we're returning that value and assigns it to y, and that's our program as it executes. But the important part to look at here is just when you click back, a nested function is a function that's called from within another user-defined function. When that happens, you almost get a second local variable. Python only executes one frame at a time. And while it's executing Fahrenheit to Celsius, you can't alter Fahrenheit to Kelvin variables either. Just like Fahrenheit to Kelvin can't alter variables that are in the global frame. So that's a nested variable, and that's how they're handled by Python. And finally, we're going to take a look at the Lesson 14 challenge program just to make sure everyone's been keeping up. And what this challenge program is a simple function that allows the user to ask for help when they're looking at one of your menus. So over here, I've got my game, Welcome to the Dungeon. I didn't spend a lot of time trying to name this program. Let's select the weapon you'd like to use. Well, I don't really know what my selections are, but I'm going to go ahead and type dagger. Now, nothing happened. Well, maybe I want a axe. No, nothing happened. Obviously, I need some help. And the program is telling me right here that I can press question mark for help, so I'm going to go ahead and press question mark. And wouldn't you know it, a weapon selection help screen pops up. It says weapon selection, and I have my choice of 4 weapons: a battle axe, a longsword, a dagger, or a polearm. I think I want the battle axe, so I'm going to select B for battle axe. And it prints a statement: the adventurer has chosen to wield a battle axe. That's the end of this program right here. It says, would you like to continue? I would. So I enter my uppercase Y, and it resets the program. Welcome to the dungeon. What weapon would you like to use? I'm going to ask for help again. And this time, maybe I want a dagger. So I'm going to select D for dagger. And it properly tells me the adventurer has chosen to wield a dagger. Would I like to continue? Yes. I can select off that menu, even if I don't know what it is. For example, I can hit P right now, and it correctly identifies that I've chosen the polearm, even though I didn't pull up the help menu. And one more time, what would I like to use? I'm going to pull up my help menu. I'm going to select L for longsword. The adventurer has chosen to wield the longsword. Would I like to continue? No. And my program breaks. It's not a game in of itself. It may be a bit of a challenge to program. It doesn't really do a whole lot. But the idea is you can create functions that are called only when the user needs help. The way that I program this, if you're trying to plan it out in your head, I ended up writing 3 functions to make this program work. I wrote an introduction function that simply printed out the heading. I wrote a make selection function that used a while loop to check the user's input. It had an input statement that asked the user to select a weapon and then checked to see if the user selected B, L, D, or P and then returned that weapon, or it checked to see if they entered a question mark. If the user entered a question mark, it called a function that printed a help screen. And my help screen was this weapon selection screen that I've got highlighted here. So that's your nested function right there. When running the make selection function, if the program encountered a question mark, it would call the nested function of display help menu and display the proper help menu on the screen. In order to write this program, you're going to have to make sure you know how to use a while loop. And you could probably do this without nested functions, but I would highly recommend trying to recreate it as I did using those nested functions. Finally, after I had those 3 functions created, I just created a main game loop that played the introduction, that prompted the user to make a selection, and then printed out the appropriate message. So that's your challenge program for lesson number 14. As always, if you have any questions, go ahead and leave them in the comments, and I will get back to you guys as quick as I can and help you with any problems that you're encountering. If you have any other programming related questions regarding Python, I'd be happy to help you out with them. Thank you for those of you who have subscribed and liked the videos. It's a big help to me. As always, have a great day, and I will see you in lesson number 15.